start triangles, which are my second favorite shape. So this is a very exciting unit where we get to jump into triangles. And we're actually going to use triangles a lot. Triangles come up in this unit. They're going to come up with similar shapes. They're going to come up with congruent shapes. Triangles come up a lot. Now, this is the only time that we're going to spend... No, that's not true. We've got 2 units on triangles this trimester, and then there's another triangle unit next trimester. So lots and lots of triangles. So today is kind of an introduction to triangles. Which, just as an aside, just talk about etymology a little bit. Tri means 3. You know what angles are now. Triangles are things with 3 angles. Well, we identify triangles. We've got those down. So there are 6 different classifications of triangles that we need to talk about. Okay? And there are 2 ways that we can identify them. The first is by lengths. And the second set of classifications is by angles. Okay? So, we are going to classify things by their length and things by their angles. And there are 3 different length classifications and 3 different angle classifications. Okay? The first one, for lengths, is scalene. And if you look in Schoology, you should notice that I did post notes on this stuff. So, like, you have all of these things written down. Scalene means they're all different. So if we have like a 3, a 4, and a 5, a 3, 4, 5, every side measurement is different, so it's scalene. Okay, scalene. Okay, most triangles are scalene. Okay, the second one. This is where none of them are the same. The second one is where 2 side lengths are the same. We have like a 6, a 6, and a 7. Keep in mind what those 2 hash marks mean, right? Hash marks on a segment mean that they are the same length, that they are congruent. So this side is congruent to this side. Okay? What we have here is an isosceles triangle. There's a definite chance I'm spelling it wrong. So if I did, sorry. Okay? So scalene means none of the sides are congruent. Isosceles means 2 of the sides are congruent. Some of you are probably already at the next triangle, which is called equilateral. If we have an equilateral triangle, all 3 sides are going to be congruent. Equilateral. And again, these notes have been posted. So we have an equilateral triangle. So, nothing's the same. 2 are the same. 3 are the same. Okay? So that's what we're staring at for their length identification. Next, we're going to look at angles. And angles work pretty much exactly the same. Okay? But I do want to talk about a couple of different kinds. The first one is, well, actually, angles are one thing. Sorry. There are 4 angles. First one is a right triangle. A right triangle, indicated by this perpendicular square in this corner. Remember, we've talked about this before. Perpendicular angles, which are 90-degree angles, we have that little square. It's a right angle. Okay? If a triangle has a right angle, it's called a right triangle. And I'll tell you right now, we love, in life, right triangles. Because we love right angles. In construction, we build stuff using right angles all the time. And anytime something gets cut in half diagonally, we end up creating a right triangle. Because you can imagine a completed rectangle here. Okay? So we use right triangles a lot. Another type of triangle, and if you remember your angles, this is obtuse. If there is one angle greater than 90, and it only takes one angle greater than 90, it is an obtuse triangle. There's also, as you can imagine, an acute triangle. Now, I want to talk about the difference between obtuse and acute really quickly. Obtuse means that I have one angle that is greater than 90. Just one. It only takes one for it to be obtuse. For it to be acute, all three angles have to be less than 90. Because if one of them happens to be 90, then it's right. And if one of them happens to be greater than 90, it's obtuse. We'll talk about this more tomorrow. But if you add up all three angles of a triangle, you'll get 180 every time. Okay? These three angle measurements, 180. These three angle measurements, 180. These three angle measurements, 180. Every single time. The interior angles of a triangle always add up to 180 degrees. Okay? So, looking at these two triangles, if I have a right angle, which is 90, these two have to be acute. Okay? If this is greater than 90, these two have to be acute. There just aren't enough degrees left over. Okay? So if you have one obtuse or one right angle, the other angles will be acute. Necessarily, they have to be. Okay? So all three angles have to be acute. The last type for angles, and we've actually already talked about this. I know I'm kind of almost off the screen here. So these arcs, we have an arc in each angle. Arcs, remember, mean that those angles are congruent. So all three of these angles are congruent. This is an equiangular. Equiangular. This should be relatively easy to remember. Equa meaning equal, angular meaning the angles. Okay, so we have equal angles. All three of them. Something that I want to point out, because this is just an additional thing that you should know. Equilateral and equiangular are the same triangles. If you have all three congruent angles, you will have all three congruent sides. If you have all three congruent sides, you will have all three congruent angles. Okay? That converse there. The if-then, if all three angles are the same, then all three sides are the same. The converse is true. When we flip it, if all three sides are the same, then all three angles are going to be the same. Okay? That's not true for anything, any of the other ones. Although I will note that these two angles in an isosceles will also be congruent. It's a little extra information. You don't need that today. We'll talk about that more tomorrow. Today what we're going to look at is using these classifications, all those classifications. If I give you a triangle, can you tell me which of these seven it is? And I'm going to tell you right now, there are both lengths and angles, so each triangle is going to be, for example, a scalene obtuse, okay? Or maybe an isosceles right, or right isosceles, okay? Or an equilateral. Actually, if it's equilateral, it's equiangular, okay? So you're going to need one of these for every single triangle, and one of these for every single triangle. Okay? So you're going to need the length, you're going to need angle measurements. The homework is posted, or at least will be in just a couple of minutes. The notes are there, so please, please, please use the notes. And I will see you tomorrow where we get to talk about triangles more, which is very exciting. They're my second favorite shape. They're so cool. Okay? So, see you in class for triangles.